Right, well thank you. This is joint work with Marosh Savatka. I should mention that I thought I had a few more minutes to present than I actually do, so I might skip over the occasional slide from time to time. To motivate what this paper's about, I want to show you a quote from a favourite trout fishing book of mine that says, "Never say I'll go tomorrow. When you get a chance to go fishing, go. If you wait until tomorrow, tomorrow will drag into next week, and next week will drag into next month, and next month into next year, and someday it will be too late." What on earth does this have to do with charitable giving? Well, if we take out the word fishing and substitute it with the words donate, as I've done here, you basically get what our paper is about. And we refer to this phenomena as inertia. The idea that there are people who have the best intentions of donating money to charity. They've even decided that they're going to donate, but because they don't have to make that donation immediately, they never actually get around to transferring the money to the charity. And that's the phenomena that we want to explore. And our conjecture is that for this inertia to occur, that it's most likely to exist in the presence of transactions costs. Transactions costs we think are important because if you decide to give money to a charity and there's no transactions cost, imagine you could just click your fingers and the money magically goes from your bank account to the charity's bank account. There'd be no reason to put off making that donation. But as well as the presence of transactions costs, we think that for inertia to exist, we need two other conditions to hold simultaneously as well. The first is that donations don't have to be made immediately, and often in everyday life they don't. And the second is that requests to donate or solicitations are received when people are busy. In other words, the opportunity cost of their time is high. And that's often the case in everyday life. Now, why is that second point important? Well, if you receive a solicitation and there is a transactions cost, but you've got nothing better to do with your time, the opportunity cost isn't going to be particularly binding, and presumably you donate quickly. So what do we do in this research? Well, here's the very brief version, and then I'll give a more detailed explanation. We use a dictator game in a laboratory setting that creates an environment that involves both transactions costs and inertia to test these three hypotheses. The first is that introducing a transactions cost in a dictator game will reduce donations. The second is that transactions costs will have a greater effect if the solicitation is received when the opportunity cost of time is higher. And one of the neat things about doing this in a laboratory context, we think, is we can control for what that opportunity cost of time is. There are some other field studies out there, for example, Marin, Rigby and Huck and Russell, that look at the context of transactions costs in a field setting, but they're unable to observe what the opportunity cost of time is. Our third hypothesis is that not being able to make donations immediately will reduce donations due to both inertia and possibly due to higher effective transactions costs. And key point I've sort of emphasised here again at the bottom, our method allows us to observe that opportunity cost of time when the solicitation is received, and I'll explain very soon how we do that. Now this paper actually includes two separate but very closely related studies, and I'll start by talking about study one. So our baseline treatment is the standard dictator game where people are asked to give some money to charity having been given an endowment, or in our case they have to earn it. Students at the University of Canterbury in this baseline, they're invited to take part in a survey. The survey had nothing to do with charitable giving. This was done in the New Zealand Experimental Economics Lab at Canterbury, and they were paid $20. The payment was made up of a $10 note, a $5 note, two $2 coins and one $1 coin. In New Zealand, a $5 note is the smallest denomination note we have, and New Zealand dollars are worth just a little bit less than New Zealand dollars for point of comparison. The reason we didn't give them a $20 note was so that when we invite them to give some money to charity, they can give any whole dollar amount between 0 and 20. Subjects were seated at cubicles, so their actions could not be seen by other subjects or by us. And after we'd paid them their money for doing the survey, this was when the dictator game comes in. Subjects were then invited to donate some or all of their payment to World Vision if they so chose, and they were told that we would double any donation that they made. So it's a double dictator game. Subjects then chose a blue envelope. They got to choose one from a box, and this contained a transfer form to indicate how much money, if anything, they wanted to donate. We needed them to fill that in for accounting purposes. We asked them to complete the transfer form and then place the form and any money they wanted to donate back in the blue envelope. And we then got them to come one at a time to the back of the lab, complete a receipt form to keep the accountant happy, and we then got them to leave the lab and place the blue envelope, whether it contained any money or not, in a red box situated just outside the lab. So note, this ensures a double-blind protocol. But two important things to note here. There's no transactions cost associated with giving money. People who choose not to give don't get to leave the lab any more quickly than people who do choose to give. So there's no transactions cost. And there's no potential for inertia. People, if they want to donate, they have to decide to donate on the spot. They can't think, oh, I want to donate, but I'll put that off till tomorrow. In our first treatment, the 1 hour treatment, this is where we introduce the transactions cost. And the nature of the transactions cost is that donations need to be placed in a secure box a 5-minute walk away. So the transactions cost is having to take that 5-minute walk. And donations could be made any time in the next hour. Now, to make sure that people could find the donation box, it wasn't a fairly well-known location, but just in case, the blue envelope contained a map showing the location of the secure box. Now, this next point's really important. This is how we get to control for the opportunity cost. As the lab session was advertised as lasting for an hour, but it actually finished after only 35 to 40 minutes, we know subjects had no previous plans for the next 15 or 20 minutes. That is, we know their opportunity cost of time was low in the time immediately after the lab session. So this treatment, we think, is analogous to the everyday life situation of receiving a solicitation when you're not busy. Now note, we've got a transactions cost here, but the scope for inertia is incredibly minimal because they've got to donate within the next hour. It's so low we assume it's zero. The 1 day treatment, or 1D for short, is the same as the 1 hour treatment, but we give people 25 hours to donate. There's a wee typo in the next point. It should say as in the 1H treatment, not the 1D treatment. As in the 1H treatment, the opportunity cost of time here is also low when the solicitation is received because, like in the previous treatment, the lab session has finished earlier than they expected it to. So this treatment includes both a transactions cost, but we've also introduced the potential for inertia, the idea that by giving people more time, that might reduce donations. Our next treatment is the next day treatment, and this involves the same transactions cost, but donations can only be made the next day. So we've ruled out the option of donating immediately after the lab session when the opportunity cost of time is known to be low. So the opportunity cost of time here is likely higher, as the donation cannot be made during planned lab time. Now I need to just explain a little bit of jargon here. We refer to the effective transactions cost as being the nominal transactions cost interacted with the opportunity cost of time, and the nominal transactions cost is the time taken to walk to the donation box. Now this effective transactions cost in this treatment is likely to be higher because we've ruled out the option of donating when subjects have time on their hands. We've also here got higher potential for inertia than in the other treatments because the donation cannot be made immediately. Now our final treatment, the next day or week treatment, is exactly the same as the next day treatment, but donations could be made any time from the next day for the rest of the week. So we've given people 6 more days effectively here to donate, which gives greater potential for inertia, but note the effective transactions cost can be no higher in this treatment than in the previous one. Note, however, that as I'll explain later, although we'd planned to run this particular treatment in Study 1, we didn't actually implement it in Study 1, it was left for Study 2. So here's a quick summary of the different effects in those different treatments, and I've already gone through these, so I won't go through them in too much detail, but note, the baseline, it's like the standard Dictator game, no transactions cost, no inertia. We introduce the transactions cost in the 1 hour treatment. We introduce inertia in the 1 day treatment, but in both those cases, the opportunity cost is low when the solicitation is received. In the next day and the next day or week treatments, the opportunity cost of time is effectively higher because we rule out the option of donating immediately after the lab session. Okay, so here's our various conjectures and hypotheses. Our first conjecture is that introducing a transactions cost will lower donations, and that gives us hypothesis 1 that donations will be higher in the baseline than in 1H and also higher than in all other treatments. Conjecture 2 is that giving people more time to donate but keeping the opportunity cost of time low when the request is received, that this will introduce inertia, and this gives us hypothesis 2, that donations will be higher in 1H than in 1D. Our third conjecture is the potential for inertia, thank you, and the effective transactions cost will be higher if the request is received when the opportunity cost of time is high, and that gives hypothesis 3, that donations will be lower in ND than in the 1-day treatment. And our fourth conjecture is that if the opportunity cost of time is low when the request is received, most subjects who wish to donate will do so promptly. And this gives hypothesis 4, that in the 1-day treatment, the majority of donations will be made promptly. And we can look at how quickly people place their donations in the box. So table 2 here gives the summary statistics for each treatment when we run the experiments. Key points to take away from this table, I think, is that mean donations are higher in the baseline than in any of the other treatments, and we get a higher percentage of positive donations. 58.3% of people give a positive amount of money in the baseline, but introducing a transactions cost reduces that quite substantially. What figure 1 shows us is a frequency of different levels of donations from 0 through to $1 to $4 donations all the way up to $20. And the sort of pink salmon-y colour there shows the baseline. And I think the key thing to take away from this figure is that when we introduce a transactions cost, this, by quite a significant amount, reduces the number of small donations, those in the $1 to $4 range. There's a little bit of a reduction in larger donations as well, but the main action is that introducing a transactions cost reduces small donations. Table 4 here is just some significance tests for whether we get statistically significantly different effects across the different treatments. And the only pairwise comparison of the different treatments there that is not significantly different is when we compare the 1 hour with the 1-day treatments. The differences between all of the other treatments were statistically significant. So what are our key results then? Well, first up, transactions costs matter. Donations are higher in the baseline than they are in the 1H treatment, and the number of small donations is significantly higher in the baseline than in all other treatments. Secondly, there's no evidence of inertia when more time is given to donate, but the opportunity cost of time when the request is received remains low. So if we compare 1H with 1D, there's no significant difference there. But a very important caveat, it could be that the nominal transactions cost is lower in the 1-day treatment than in 1H. It could be that there were people in the 1-day treatment who were going to be passing by that donation box the next day anyway. And if that's the case, it could be there is an inertia effect, but it's cancelled out by the higher transactions costs. Our third key result, transactions costs have a bigger impact when the solicitation is received at a time when the donation cannot be made immediately. That is, donations are lower in the next day treatment than in the 1-day treatment, and they fall from $1.72 in the 1-day treatment to $1.20 in the next day treatment. These differences could be due to the effective transactions costs being higher, or they could be due to inertia, and we can't really tell the difference. Very quickly, given the option of donating promptly, most subjects did choose to donate promptly. In the 1-day treatment, we had 14 subjects who gave a positive amount of money, 12 gave the same day, only 2 put off donating to the following day. And that's consistent with the notion that most subjects perceive the opportunity cost of time as being low immediately following the lab session. I now want to talk very quickly about study 2. In study 1, donations had got so low by the time we got to the next day treatment that we decided not to run the next day or week treatment in case we couldn't observe a statistically significant difference. What we did in study 2 was changed our protocols in a couple of ways to try and increase average donations across the 2 treatments so we could observe differences between ND and NDW. And basically the 2 things we changed were as follows. Subjects were recruited to take no more than 30 minutes to take part in a decision-making task, and they were paid $10. Having been paid their $10, they were given an envelope containing another $10 as a windfall gain and asked if they'd like to donate any money to World Vision. Key point here, the money they're being asked to donate is a windfall gain. They didn't have to earn it. We also told them what World Vision would use the money for, to immunise kids, rather than in study 1 where we didn't tell them what it would be used for. So in terms of our results, we find in the next day treatment that the mean donation is a bit higher than in the next day or week treatment, $2.37 versus $2. We get a higher proportion of positive donations, 31.7% compared to 26.4%, but these results weren't quite statistically significant. So we do find an effect, but not a statistically significant effect. Just note here that most of the donations were made the next day, 13 of them, or on the last possible day. There were very few donations made in the middle there. But key point from study 2, donations are lower when people are given more time to donate, but this difference is statistically insignificant. Very quickly, some policy implications and conclusions, and then I'm done. Introducing a small transactions cost reduces donations, but this is largely due to a reduction in small donations. So if the charity faces a significant marginal transactions cost of processing donations, a lower number of small donations may not actually be a bad thing. If it costs them a lot of money to process a donation, they may not want $1 or $2 donations. On the other hand, if the charity faces a low marginal transactions cost of processing donations, they should seek to minimise the transactions cost to donors. And street collections would be an example where the transactions cost would be low to both parties. Another key point that I omitted to put on the slide is that our results would tend to suggest it's important when soliciting to catch people when they're not busy, when their opportunity cost of time is low. So in conclusion, introducing a relatively small transactions cost reduces donations. This effect is greater when the opportunity cost of time is high when the request is received. This could be due to inertia or to the higher effective transactions cost, and we found no evidence of a statistically significant inertia effect. For those of you watching the webinar, ignore that table. That was just in case anyone had any difficult questions about figure 1. So that's it, I'm done, and hopefully there's time for 1 or 2 questions. So the charity is World Vision, the New Zealand branch of World Vision. So I'm assuming you've all heard of World Vision.
There are alternative ways for the recipients to potentially make donations, so they could donate in the box across.
Yep, okay, so your concern is what if rather than giving us the money, they decided to hold off and donate it to World Vision or another charity themselves next week. That's a good point. Note that we had a matching subsidy here. We said that we'd match their donation dollar for dollar for that very reason, to make sure that if they did want to donate, that they'd give the money to us rather than donate independently. Yep. Was there a question up the back? Or?
Yeah, I was going to ask you, in terms of the results necessarily, just with inertia or transaction costs, or whether you might also consider safety institutions. So, if it's one-shot experiment and gives you lots of time, there are some charitable activities where inertia probably is more important than safety. So, I drive home every day. I listen to National Public Radio. It's a perfect example of inertia. Every day I'm like, oh, you want to do something. Here, when the subject's leave, they're not necessarily reminded of the experiment the next day. They maybe just forget. Instead, do you consider that a meaningful difference in terms of your results?
Right, so your point is that in everyday life there'd be constant reminders that you haven't given to the charity. I guess we'd see our experiment as maybe being analogous to the situation where you get a one-off letter or a one-off email from a charity asking for money, rather than the sort of scenario you're referring to where you get constant reminders from the charity, say through listening to a radio message or something like that. Yep. Yes. Yeah, I think that's a good comment. I'm not sure I actually have a response to it, but yeah, I take your point, and I think that's something that we need to think about. Yeah.
Part of that, like, has to do with whether people are regular donors or not regular donors, have they participated in this type of activity before or not, there like different types of inertia effects or transaction cost effects.
Yeah, and the way that we designed our lab experiment, we could have, if we wanted, collected data in the survey we did on people, but we'd have no way to kind of match that with whether subsequently they did donate money. I guess we could have designed ways to do that, but we wanted to make sure that the perceived level of anonymity was constant across all of our treatments, and that's why we quite deliberately didn't try to match individual characteristics to people's behaviour. Yeah.
Okay, well, we should stop there. Thank you very much.
Thank you.